Hey guys, welcome back to my channel. Today we're starting a new series, something that will hopefully help me and also help you, especially with this weird situation that we're all in. This is going to be me attempting to help you learn A2 maths. So not the first year of A level, second year of A level, but depending on what course you do, this may come into either year, or even if you're from America, hi, welcome. But episode 1, what is a radian? Like, what is this? You will be hearing about this, you'll be using it, but what actually is it? Well, I can tell you that a radian is another form of an angle, another form of measuring angles, different to degrees, you know, out of 360 around the circle, and we kind of get so familiar with this concept of degrees, it is quite difficult to switch to this new form, which is radians, which makes everything actually so much easier when you really consider it. Yes, well, there are going to be a lot of decimals rather than nice whole degree numbers, but it's actually a very nice way of working out angles and having things. Now there are other arguments, but you know, we'll get into it. And the first thing is, how do I work out what a radian actually is? Well, let's go to my board. Hi, I'm here. What is a radian? Now, here's pretty much the simplest explanation I know is if we draw a sector of a circle, right, we'll call that L, and we'll call, obviously this is the radius, that's being the center, and this is like some theta degrees. If we know that R equals L, so this thing here is the same length as the radius, we can work out what theta is. And basically, if that is the same length as that, then theta will be in radians, or theta will be one radian, sorry. 1 radian. And that's kind of the simplest form of how you work out what 1 radian is. So let's work out the exact measurement of 1 radian. So we know from using degrees that how you work out this length here. It's going to be the formula for the circumference of a circle, which is, let me switch colour to blue, which is 2 pi r, 2 pi times the radius, gives you the entire way around the circle, and then if we multiply this by the r number of degrees in this, out of 360 we get that bit. We can find out what part of a circle, or what part of the circumference circle that is. So it's going to be equal to L. But we know a new fact. We know that in this case L is equal to R. So if we substitute in L here, we can now simplify to get theta. So let's multiply everything together and see what we get. 2 pi L theta over 360 is equal to L. We have an L on both sides. They can cancel. This 2 and 360 cancel to give you 180. So then our new thing is pi theta over 180 equals 1 at this point. And then if we multiply up and get theta by itself, we're going to go for pi theta equals 180, theta equals 180 over pi. And 180 over pi is our definition of 1 radian. So let me write it. This framing's a bit off. I'm going to move down. There we go. That is slightly better. So we now know that 1 radian is equal to 180 divided by pi. And what is 180 divided by pi, you may be asking? Well, it's fortunately equal to 57.3 degrees, which is not a very nice number, but this is kind of the new term in which we're going to be working out stuff. So we know that this here is 1 radian. Now you can actually work out how long that is and work out the radius, but we don't need to do that for now. So, another thing you may be wondering is how to convert between radians and degrees. Why is this useful? Like, what is this even for? Well, let me clean the board, and then we'll be back to really work out how to convert between degrees and radians. Okay, we're back. So, we know that, you can see this here, 1 radian, we'll call them rads because it's easier than radian every time, is equal to 180 divided by pi degrees. So this is going to be our conversion standard. And say I wanted to convert something like 30 degrees to radians. How am I going to do this? Well, we know that 1 radian is 180 divided by pi. So 30 times pi, we're basically going to divide 30 by this here. We're going to flip it over and multiply them together over 180. Is going to give us, well, if you divide 30 by 180, what do you get? You get 1/6. And still pi on the top, pi over 6. We see symbol just says radians. Pi over 6. So we're saying that 30 degrees is pi over 6 radians now. Interesting. That is 1/6 of half a circle, or 1/12 of an entire circle, because 180 divided by pi, 1 radian basically tells you that half a circle, which is 180 degrees, is pi. Pi is 180 degrees, because if we have 1 radian, if we had like the equivalent of 180 degrees, you get pi, because pi equals 180 divided by pi, bring up the pi cancel, you get 180 degrees, you know, maths. But yeah, half a circle is pi, so pi over 6 gives you 1/6 of half a circle. Now this comes into your argument, why do we not use tau rather than pi? Because tau would be so much better, because then the whole circle, tau by the way, is 6.28318, you know, 530717958, etc, etc, etc. Tau, I agree, tau would be much better to use, but we don't, we use pi, and pi works. It's messy, slightly messy, but you know it's fine. Anyway, pi over 6, so that is conversion. So to get from degrees to radians, right, you're going to divide by 180 over pi. Or you can think of it, radians are also called pi radians. I mean, they can be called pi radians, so if you want to think about it, you're converting the thing that's not pi into something that is pi, so you can think you're going to be multiplying it by pi over 180. Just another way of thinking of it. So, if we go for another example, and this time you can try and convert, while I wrote this book, my board is going to be blue by the end of this. Let's convert 45 degrees to radians. Right, now pause the video and see if you can convert 45 degrees into radians, and then I will do it after. So hopefully you have worked it out. If not, that's fine, I will do it now. So 45 degrees, I like to think about it by, we're turning it into the thing with pi, 180. It's going to be equal to, so what's 45 over 180? Well, you're going to be like, I can't do maths. You think I can do maths? Well, 45 times is 90. This gives us a quarter, so pi over 4 is going to be our radians. Now when you think about this, 45 degrees is a quarter of pi. Remember, pi is going to be half a circle, right? So a quarter of that is this. There's our 45 degree angle, which is a quarter of your half circle. So that is a very useful one to know. 45 degrees is pi over 4. But you can always think about it in terms of half circles, which is quite nice. Obviously it would be slightly nicer to think about it as full circles, but we can argue about that another day. Okay, let's try the other way. What if I said I wanted you to convert, oh, someone's bringing a pen in, 2 radians to degrees. 2 radians to degrees. Now how are we going to do this? Well, remember we multiplied by the thing with pi. This time we're just going to simply divide by the thing with pi. Or we're going to multiply by 180 divided by pi times 180 to get into degree format, and then divide it by pi, because we're removing the pi-ness from it, if you know what I mean. Because you don't really want the pi-ness there. We're getting rid of the pi. That's just how I think of it. It's weird, but you know. Okay, so we're going to multiply 2 by 180, obviously gives you 360. 360 divided by pi, and this is in degrees. Now obviously you're probably going to want to leave it like that, but if you work out in the calculator, did I write this one down? I didn't write this down, great for me. Okay, I got my calculator. So 360 divided by pi gives us 114.59 degrees. Right, so obviously that's not a very nice number of degrees, but that is what 2 radians are equal to. Now, you can try one, and I'll make the actual calculations that you can do in your head. So let's go for 3 pi over 4 radians, 2 degrees. Now pause the video and see if you can do this now. Okay, hopefully you did that. If not, obviously still fine. And I will convert. So we're obviously converting this to degrees. Remember, we want to remove the pi-ness. That's how I like to think of it. So 3 pi over 4 multiplied by 180 to convert to degrees over pi. So we want to remove the pi-ness. Pi's cancel. Nice. And it's 3/4 of 180 now. 3/4 of 180, you can probably do in your head. I'm not great at that sort of thing, but this gives us 135 degrees, or you can think about it as 1/4 of 180 is 45, and then multiply by 3 and you get 135. And that is another way of, well, this is another example of converting to radians. So that is this first video. What is a radian? Converting between the units. Hope you enjoyed. If you did, thumbs up. Comment down below. Tell me if this was helpful for you. Tell me if you needed this. Tell me if you want me to continue, or if you think I should stop. And I really cannot teach. Let me know in the description below or in the comments below. And don't forget to subscribe to the channel. I will be posting these on my A2 Maths playlist, which I will be creating. But yeah, thank you for watching, and I'll see you all again later.